welcome today. This video is actually being recorded on, as you can see, the 18th. But it's going to be posted on the 19th, and this is the first of two. I'm also going to record one later. It's going to be posted on the 20th. I'm going to be gone, and I can't record a video on the 19th and 20th, so I have to pre-record them today. Yeah. Anyways, let's get into this. A square is inscribed in an equilateral triangle with perimeter 36. The square has a side length of a root b minus c, where a, b, c are positive integers and b has no perfect square factors greater than 1. Okay. So, how is a square... It's like the first idea, but when I hear inscribed, I think it's like tangent only at... Can't you inscribe it? No, because this isn't tangent. So, maybe like this? No, but then it can't possibly be like that. Yeah, I think that's the only way. So, equilateral triangle with perimeter 36. So we know that this is equal to 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 this. This is equal to 6. We know you can split this down center for a right angle. So this entire thing is 3. Let's do a better representation. Okay, there we go. We could also do this. So this is a 30, 60, 90. This is the square. That makes no sense. Oh, because this is half the side length. So if I do this, and then it's like this, but I have to make it equal. So like that. Like that. Bam. Bam. Okay. So we know that this entire thing is 3. This is 6, and this is 3 root 3, I believe, because 3 squared plus 3 root 3 squared is equal to 36. 9 plus 18. 9 plus 9 times... Oh wait, no, yeah. No, this is right. 3. So we're trying to find the side length, so... I mean, we also know that these are angles. What else do we know? Can we tell that angles are the same? Yeah, we can. But we don't know anything in particular about this angle versus that angle. No, we do know. What am I talking about? This angle is the same as this angle is the same as that angle is the same as that angle. But we don't know anything about the side. Okay, so if we take... Let's call this A, let's call this B, let's call this C, let's call this D, let's call this E, let's call this F. We know that C plus D is equal to 3. A plus E is equal to... A plus E is equal to 3 root 3. And... B, C plus D, right? Yeah, B plus F is equal to 6. We also know that C is 1/2 E. So, 1/2 E is equal, 1/2 E is equal to C. So I could just replace e is equal to 2c. So that could just be replaced with 2c. What else do we know? Okay, what we could do. Oh, I was gonna say we could scale it, but we cannot scale it because this is not that. Hmm. Oh, we can also say a squared plus 4c squared. Oh no, I lied. A squared plus c squared is equal to b squared, and 4c squared plus d squared is equal to f squared. Okay, I think this is probably enough. If we could get rid of this, because we're trying to find e, or 2c. So what we can do is divide this by 4c squared plus d squared plus 1/4 d squared is equal to f squared. C squared is equal to f squared minus that. So we can say, or it's 1/4 and then it'd be b squared minus, what is that, a squared? I'd multiply by 4, so f squared minus d squared is equal to 4b squared minus a squared. You can't take the square root of both sides, that just won't work. So now we have an equation relating these variables, but what else can we do? Wait, let's get this. F squared minus d squared is equal to 4b squared minus 4a squared. So, we can also do here b plus f is equal to 2c plus 2d, which is just what, is that what we have here? B plus f? No, f plus d squared. Interesting. Why don't we isolate what we can do is we could replace the variables here, so what we could do is multiply everything here by root 3, and then, okay, so root 3c plus root 3d is equal to 3 root 3, and we have this, so then we have, we have 3 root 3 minus root 3d is equal to this. Shoot, I did that wrong. I did that wrong. What I'd really do is divide by half here, so c plus, or 1/2, divide by 2, not by 1/2, plus c is equal to 3 over 2, 3 root 3 over 2. Then subtract this, so then I have d, 3 minus d is equal to 3 root 3 over 2 minus 1 over 2a, so 6 minus d is equal to 3 root 3 minus a, and then we have 6 here, but that doesn't include any of these variables. What other equation do we have that includes these variables? D and A, D and A, D and A, D and A, none of these. Well, we also know that D, yeah, no, never mind. C plus D is equal to 3. Wait, let's start over. Let's just only use E, because E is what we're trying to find. So we know E squared plus D squared is equal to F squared. E is equal to the square root of F squared minus D squared. What other thing includes E? So A plus E is equal to 3 square root 3. And then we can find A in order to solve this, I guess. Or maybe we could replace more things. D, and can we replace stuff with D? Yes, we can. D is equal to D plus C, I believe, plus C is equal to 3. C is equal to 3 minus D. We also know that, is it 2C is equal to E? 2C is equal to E. So C is equal to 1/2 E. So 1/2 E is equal to 3 minus D. So we have D is equal to 3 minus 1/2 E. E squared plus 3 minus 1/2 E squared is equal to F squared. So E squared plus 9 minus 1, oh shoot. 9, it's just difference, it's not difference of 2 squares. So it'd be this times this, 2 times that. So it'd be minus 3e plus 1/4 e squared is equal to f squared. Then can we do something with f? We know f plus b is equal to something. Oh, these in of themselves are 30, 60, and 90, so that will give us, that's the key. That is the key. So if we take sine of, this is 30 degrees, is equal to SOHCAHTOA no wait, no, so OHD over F is equal to sine of 30, oh my gosh, well, is here, so that's like root 3 over 2. Cosine of 30 is equal to E over F is equal to root 3 over, wait, what is it, what am I talking about? Cosine of 30 is equal to 1/2. So so that means if we cross multiply, 2e is equal to f. And then we have here, so here we put in 2e. So we have we have 3 over 4 e squared plus, or minus 3, why am I doing a quadratic? E squared plus d in terms of e. We need these two, right? So that's tangent. So tangent of 30 is tangent of 30. So get d over e is equal to, is it root 3 over 3? Because it's sine over cosine. Or no, is that just root 3? It's just root 3. Is equal to root 3. So that means d is equal to root 3e. Root 3e. So it'd be 3e squared is equal to 4e squared. Brother, what did I just do? Why did I do that? Doesn't give me anything. We need to assign a value. In order to do that, we need to use this or this. We don't want to include A or B because those aren't needed. We could do C and D. So C plus D is equal to 3, right? Oh my gosh, we've been doing this problem for so long. C is 1/2 E plus it's root 3 E is equal to 3. So, E times 1/2 plus root 3 is equal to 3. E is equal to 3 over 1/2 plus root 3. If we simplify this, multiply by root 3. So 3 root 3 over, multiply by 2 and root 3. So 6 root 3 over 1 plus 3 is equal to E, which is 6 root 3 over 4. No, I did it wrong. First, I'll multiply by 2. So we have 6 over 1 plus 2 root 3. 2 root 3. Now I'll multiply by root 3, which is a bad idea. Now I multiply by 1 minus root 3. So 6 times 1 minus 2 root 3 actually over that times that, which is it's squared, so minus 2 times 4 times 3. So 6 minus 12 root 3 over 1 minus 12. So 6 over negative 11 plus 12 over 11 root 3. Okay. A is equal to 12 over 11. B is equal to 3. C is equal to 6 over, or negative 6 over 11. Okay. A plus B plus C is 6 over 11 plus 3. Let's find out what I did wrong. We know A plus B plus B. Wait, whoa. We know C plus D is equal to 3. C plus D is equal to 3. And we could find both these in terms of E, right? C is in fact 1/2 E. D is 30, 60, 90. So if we take tangent of 30, right? Or we could do tangent of, Wait, what? We could do tangent of 60. I don't know. Wait. We know tangent of 30 is equal to sine over cosine. Sine of 30 is 1/2. Okay, that's why cosine of 30 is √3/2. E is equal to 3. Multiply by 6. 3e plus... Nope. Still did it wrong. Cosine, so good. So d over e is equal to √3/3. 3d is equal to √3e. D is equal to 3√3e. Okay. √3/3 e is equal to 3. So, we have multiply by 6 on both sides. 3e plus 2√3e is equal to 3. So e times 3 plus 2√3 is equal to 3. E is equal to 3/3 plus 2√3. Now we need to take the conjugate, so we have 3 times 3 minus 2√3, and then it's just the square, so it's 9 minus 12, which this is 3, so it's just 3 minus 2√3. So 3 plus, oh shoot, which, 3 plus 2 plus 3, I'm just going to ignore that it's not in the right form, but it's fine. 3 plus 2 plus 3 is, 8. Let's just see, does it say positive? Positive integers, yeah, that makes no sense, but it's fine, I must have somehow done something wrong. As of always, I got 8, let's check, is it 8? No, it's 63 somehow. I got the right diagram. I don't even know that they're wrong. It's fine. Thanks for watching. I'll see you guys tomorrow. Or, I'll see you guys when I see you guys. When I make videos on the normal day again, which will be the 21st. Bye.